Need your AI to interact with custom tools, but tired of manual API glue code? You'll see how to connect Google's Gemini models directly to a FastMCP server with just a few lines, letting the AI call your Python tools like rolling dice without writing a single integration layer. The pattern works for local or remote servers, and we'll walk through the exact setup. From FastMCP import client. From Google import Gen. Import Asyncio. MCP client equals client, server, hi. Gemini client equals Geni, client. Async def main. Async with MCP client. Response equals await Gemini client. AO models, generate content. Model equals Gemini 2, 0 flash. Contents equals roll 3 dice. Config equals Geni, types, generate content config. Temperature equals 0. Tools equals MCP client. Session, hash pass the FastMCP client session. Print response text. If name equals main. Asyncio, run main. This demonstrates the AI tool integration pattern, where backend functions become directly callable by AI models through a standardized interface. The key concept is exposing Python logic as declarative tools that AI systems can discover and invoke, while the framework handles all transport, serialization, and protocol details. What makes this distinctive is the seamless bridge between human-readable code and AI-accessible capabilities without manual API development. The pattern works by combining two complementary systems: a tool registry, FastMCP, that exposes typed functions, and an AI client, Gemini SDK, that dynamically discovers and invokes those tools when needed. The separation of concerns is critical. Your server defines what tools exist and their behavior, while the AI determines when and how to use them based on natural language requests. This creates a loosely coupled system, where neither component needs awareness of the other's internal implementation. This approach solves the problem of AI orchestration boilerplate by eliminating manual API contracts, client libraries, or protocol translations. It's particularly valuable for rapid prototyping of AI-assisted workflows, where you want to expose backend capabilities without building custom integrations. The trade-off is reduced control over the invocation protocol. But for most use cases, the productivity gains outweigh this limitation when working with supported AI platforms. Let's break it down line by line. From FastMCP import client. Imports the client class from FastMCP, the core interface for creating AI callable tools. This establishes the connection bridge between your Python functions and the MCP server, enabling tool registration and execution. From Google import Gen. This imports Google's generative AI client library, providing the Geni client interface for model interactions. It's the official SDK for accessing Gemini models, handling authentication, request formatting, and response parsing under the hood. Import Asyncio. Imports Python's built-in Asyncio library, the foundation for writing asynchronous code. This enables non-blocking I/O operations, which is essential for concurrent network requests like calling the Gemini API and FastMCP server without freezing the application. The event loop it provides will drive all async functions in the script. MCP client equals client, server, hi. Instantiates the FastMCP client, establishing a connection to the server defined in server, Pi. This client handles all communication between your Python code and the MCP server, enabling tool execution and session management. Gemini client equals Geni, client. Instantiates the Gemini API client. This is the entry point for all AI model interactions, handling authentication, request routing, and response processing. The client manages the connection pool and enforces rate limits.
Async def main
defines the async entry point for the program. This coroutine function becomes the main execution flow, handling all asynchronous operations like MCP connections and Gemini API calls. The async def syntax enables await expressions for non-blocking I/O.
Async with MCP client.
Context manager pattern for async connections. The async with block ensures the MCP client properly initializes and cleans up the connection, preventing resource leaks even if an error occurs. This is the standard way to handle async resource management in Python.
Response equals await Gemini client. AO models. Generate content.
This triggers the asynchronous content generation call to the Gemini API. The AO namespace indicates we're using the async client, which prevents blocking during the AI response. And generate content is the core method that sends prompts and receives completions.
Model equals Gemini 2, 0 flash.
Specifies the Gemini model version to use for content generation. The Gemini 2.0 Flash variant balances speed and capability, optimized for low latency tasks like this dice rolling example. Model selection directly impacts response characteristics, cost, and performance.
Contents equals roll 3 dice.
This is the natural language prompt sent to the Gemini model. The string roll 3 dice defines the user's request, which the model will process and potentially delegate to tools like FastMCP when appropriate. The prompt's clarity directly impacts whether the model correctly routes the request to your dice rolling tool or attempts to handle it natively.
Config equals Jana. Types. Generate content config.
This instantiates a generate content config object, which controls how the Gemini model processes requests. It lets you set generation parameters like temperature and tool integration, ensuring consistent behavior across API calls.
Temperature equals 0.
Sets the temperature parameter to 0, eliminating randomness in model responses. This ensures deterministic output for predictable results, critical when you need consistent behavior like dice rolls.
Tools equals MCP client. Session. Hash pass the FastMCP client session.
This injects the FastMCP client session as an AI tool, enabling the Gemini model to call your Python functions. The session object contains all registered at MCP tool functions, making them executable by the AI. This is how you bridge AI capabilities with custom backend logic. This closing parenthesis terminates the generate content config object definition. It finalizes the configuration for the Gemini API call, including the temperature setting and tool integration that enables FastMCP session handling. This closing parenthesis terminates the generate content config initialization, finalizing the AI request configuration. It locks in the temperature setting and tool integration before passing the config to the content generation call.
Print response text.
This outputs the AI's response text to the console. Since we configured the model with temperature equals 0, this will always print deterministic dice roll results, making it reliable for testing and debugging.
If name equals main.
This is Python's standard entry point guard. It ensures the async event loop only runs when the script executes directly, preventing accidental execution if this module is imported elsewhere. critical for reusable modules that shouldn't auto-execute on import.
Asyncio, run main.
This boots the async event loop and executes main, the standard pattern for running async code in Python scripts. Without this, the coroutine would never execute, and the program would exit immediately. FastMCP Gemini integration. The session bridge between FastMCP clients and Gemini SDK transforms local Python functions into AI-accessible tools without protocol translation layers. Passing the client session directly in the Generate Content config bypasses manual tool registration, but requires the session to remain active during the entire AI interaction. This pattern eliminates the need for custom API wrappers while maintaining full type safety and schema validation.
The tool that never speaks its own name becomes fluent in every language.